Outlook notifications. Hi, everyone. Thank you. Appreciate the time. Oh, shoot. The thing's covering my notes. Sorry. Good morning. Welcome to AWS Community Days. And thank you, Margaret, for organizing all this and the various AWS community leaders here today. And thanks for Morningstar for hosting all this. So just to get into it, so using machine learning to solve life's problems. Kind of sounds like a loaded question or a loaded statement, but hopefully we break that down for you and able to find use cases similar to this in your own lives where you can use machine learning and AWS to solve your problems. As well as I'd love this to be interactive at some point. I want you to hopefully raise some questions. So after the fact, we'll have a mic, or you can yell first questions. So I'll definitely save some time. So think about anything. You have any questions about the presentation? All right. Here we go. So before we get started, I'll spend a few minutes just introducing myself. So I'm Stuart. I am a senior solution architect at AHEAD, which is a professional services consulting company located right here in Chicago, not far from where we sit. My role is really building data platforms and enabling companies to leverage machine learning analytics to solve their business needs. My background is actually in computer networking, based in old school data centers, but quickly made the move into Hadoop and big data, and really understanding how to best leverage those, the data that every organization has, using Spark, Hive, and things like that. As well as I once proudly held 12 AWS certifications that were all active. That was all of them at the time. And last but not least, that's at least privy to this talk, is I love to ride bicycles. Okay. So now just to set the stage, back in 2020, back in 2020, trying to get to work, living here in Chicago. I work close to here. I live not too far, 4 miles from here. You can take the train. Back then especially, trains were running slow. They had a shortage of conductors, and I wanted to get to work. It took about 45 minutes, just given it was not close to the station. In the city, there's probably several options. You could walk, I guess. But I love to ride bicycles, and I can cut the commute in more than half at that time by biking. There's a bike lane. You get to view the city, get some sunrises over the downtown as you come in. It works great. The only fact is, sometimes the year gets hot. And actually, in fact, 2020 was the hottest year on record for Chicago, dating back to when the records began in 1871, which is actually the year of the Chicago fire, presumably destroyed records before that. But did he have a solution? So hopefully you saw as you came in, there's actually a Divvy location right next to this building, which is how I got here today. They started rolling out e-bikes in July of 2020. They e-assist, you don't get tired or have to work very hard to get in. So it was a perfect solution for getting to work. I could slowly get ready. I could look at the app when I get up in the morning, see if there's e-bikes available, set my time, shower, and get ready for work, which worked great. If it got too hot, I could not be too tired. And one summer's day in August 2020, so shortly after they rolled out the e-bikes, I checked in the morning. There's 3 e-bikes available. I had a presentation that morning. Hop in the shower 45 minutes later. Takes a long time to shower, not because of the hair. I don't know. I walked to the Divvy station, and lo and behold, there's none there, which is problematic if I have a meeting. So I only took the only option. I didn't have time to hop on the train. Took a normal e-bike, very heavy and slow. Got to work and arrived sweaty. That's what it's coined as now, not because of me. I don't know. But attended my meeting. Went on with my day. It's just not a good look for me. But in that meeting, I had a little aha moment. There's got to be a better way. I'm building machine learning algorithms for my clients every day. I'm learning to store their data in data lakes and warehouses, and leverage machine learning tools to predict, all kinds of hard business problems. On e-bike, it's got to be a pretty easy thing to figure out. So I started to look and say, what do I need to build a machine learning algorithm? I need historic data. Where can I get that? I need a platform to host some of these tools. So I started to look around. I know Chicago is pretty good about open data. And I found they actually do post the Divi data of where all the bikes are at all times. It's hard to read. You don't need to really figure out what it is, but there's an API available with a JSON document where all the bikes are. And even I checked back yesterday, and they added all the scooters that are at stations as well. So I think there's a future enhancement coming to this application. But it's a nested structure of how many bikes are available, how many e-bikes are available, how many docks are open, and a few other things. So I figured out how can I store this effectively so I can write a machine learning algorithm. Phase one, and this is dating back to almost 3 years now. But I leverage, we work in the cloud every day. Hopefully we have tools available to us. Maybe even we can have an account paid for by work. So I use the tools I often use. So I used AWS SAM, which is the serverless application module to write the application very effectively and test locally and deploy up. I created a Lambda function. I think back then I was using Stack Overflow, but I think you could just use ChatGPT nowadays to write some code to query the API and store it in S3. I'm storing it in a time-stamped file format and pulling from their API there. Messy code, but and originally I was also pulling from the Dark Sky API, which is weather data, thinking maybe weather would be a big contributor to whether bikes will be available in the future. Interestingly enough, it wasn't, and it was a lot of work and a lot of very expensive joins and a lot of data. Looking forward, and after joining them, across like non-equal timestamps, if the algorithm found that previous volatility, so whether bikes go from 1 available to 4 available to 1 to 3 to 0, was a better indicator of future volatility than weather, which was a surprise to me. As well as the weather API was deprecated after Apple bought them. And so for here, I'm storing all the data in an S3 bucket, just in JSON format. It's not partitioned in any way besides the timestamp. And I'm using Event Bridge, which all is coded into with SAM for scheduling to run every minute. So I can do that historical time series. And most time series algorithms, to give you the full availability of the options, every minute is how often they work. So every 5 or 15 wasn't really as good an option. As of today, there is over 650,000 files in an S3 bucket, and it's totaling about 300 gigabytes of storage. It's not terrible given the cost. So step 2, I need to find value in this. It's nested data. It's the JSON document. Most algorithms don't accept documents as input. So I need to figure out how to parse this data and find value. So I want to predict per station for bikes. I don't want to hear the whole Chicago per se. So I figure I have to unnest the data and really parse it out. So I could use Athena. I initially used Athena, which is their serverless SQL service, built on the Presto for on S3. But I wanted to get a little more performance. And to be honest, I just wanted to test out Snowflake, which is a serverless cloud data warehouse. It's also built on AWS as well under the hood. So I ingest the data in. You can have S3 as a source, and just load it in as each document is its own record in the database as just the raw data to keep that raw data in place. Then I'm able to really do some light ETL or cleaning to parse it out and to break apart all the documents, and really put each row as its own. Every station is its own row. As well as it has epoch as time, so put it in a standard timestamp in central time, unnesting and pivoting the tables so that it's not just like a multiple nested structure, so it doesn't work well for tables or machine learning algorithms. As well as I set up an auto ingest, so there's ability to, when S3 lands, you can set up events out of the bucket, and it goes into a queue, and Snowflake auto ingests it, and I have a job to put from the staging table into like the fact table. That's great. So I have all the historical data. That's like, step one of machine learning algorithms. Next, I had to figure out how can I find value in this data. My goal is so I can wake up and know if I have to like get to work quickly and shower there, or if I can slowly get ready, have breakfast, then go in. I'm not a data scientist. I know how to like do some data engineering, but I need a tool. Your obvious answer might be SageMaker, given we're at an AWS conference. At the time, they didn't support time series forecasting. I looked at another tool, and gratefully, Ahead is a partner of DataRobot, and I have a free account. So that is a stipulation in this scenario. But they offer time series forecasting, as well as some out of the box. And they're also a SaaS platform. So everything in this table is serverless, essentially. I mean, there's virtual warehouses underneath the hood of Snowflake that's doing the jobs, but they auto sleep and auto resume automatically, and it's running on a very small cluster. And thankfully, nothing's billed to me. But for DataRobot, I'm able to get set up a JDBC query into the fact table, and I essentially just tell it what I want to predict. So the featured target or target variable is I create a Boolean function within Snowflake, and it's a Boolean function within Snowflake as like the target variable. It's a Boolean function of are there more than one e-bikes available? I don't really care if there's 4 or 2 or 1. I just want 1 available. And so I set that in Snowflake as like the target variable. So I point that DataRobot at the table and say, that's the target. You have all this historical data, but tell me over the next 10 hours, what's available. So essentially pump in the source table. Source query is like looking at the last 10 hours. And I say, tell me the next 10 hours. And it does all the feature engineering, like is it weekday, is it weekend? It doesn't have weather data. All it has is the historical. It does look backs of 30 minutes, 60 minutes, 2 hours to see what's the volatility of each station. Sorry. And then it creates the prediction file and writes that back to Snowflake. From there, I'm able to, initially it was Streamlit, which is a company that Snowflake acquired maybe a year or 2 ago. And it's a Python-driven SaaS offering for building web pages for data applications. It's very designed for creating connections to databases and visualizing data. And it's free. It connects in with your GitHub, et cetera. Later on, just to get a little better UI, we changed it to Power BI. But again, we're not running any servers, and it kind of someone offered to help for one piece and created a nicer UI than I created. It's crazy, but as of today, there is over 600 million lines in that fact table alone, and this job continues to run even today. Here is the future iteration of sweatyross.com, and yes, my employer does own that URL. This is the currently next version coming out soon. I don't know when I get approval to publish it, but the Streamlit app is still up. But it's showing a map of Chicagoland. There's over 1,000 stations around Chicago. And the dots indicate essentially like what's the probability of there being e-bike in the near future. But then you can click on each one and drill down and visualize the data. And this is what's coming out of Snowflake, or out of Snowflake, but from the DataRobot predictions of over the next 10 hours, what's the availability like? Is it going to be 20% in 20 minutes? Is it going to be 80%? And then over the next several hours. So what are your chances, your best chances of getting an e-bike at that station? So you can select on a few and visualize it. But you'll see here in the next short time, it's going to be very low percentage of chance, probably 17. And then in the future, towards the end of the day, you're likely to get a bike. Given the station's probably near some apartment buildings, they leave work, they come there. But you never know. I was trying to do some machine learning in my head, and I thought, why not use the data to visualize it instead of just second guess? This is super useful. So now I can, even when I go to bed at night, I can see like how early I have to get up. Can I sleep in if I'm out late? And how do I get to work quickly versus having to ride a standard bike, which are very heavy and slow. I promise, especially in 70 or 90 degree days in Chicago. So that was that was the app. It's still up to date. One piece I'll touch on here is things change often. I checked the web page this morning and it was down, which is demo gods never help out. But it was working yesterday. But some of the key takeaways is we can all do this. This is not like I didn't have to use any machine learning algorithms myself. I really let DataRobot do that. It tests all kinds of algorithms like k nearest neighbor, extreme gradient boost, all these different things. I don't know what they do. it just tells me how to predict what I want to predict. Building simple lambdas that you could essentially ask ChatGPT to create for you. It costs me nothing, to be fair. But overall, I mean, number of every single minute lambda and function is going to cost be under the free tier, as well as probably the S3 storage. And I think we all have some of the skills. We're in this room because we enjoy AWS, and I think these are all very attainable things. Next is there's use cases like this all over. I mean, there's e-bikes available in most major cities. I know walking around New York City, I'm like wondering, what's the chance I can get a city bike here tonight after we go to the bar? But everyone probably has a Nest thermostat. You can do harvest that data and see what your usages are. Even your garage door opener, we have data being produced everywhere. And this is just a single example of what you can do just with simple tools. Things change often. Yeah, the website broke today. I don't know why. I think they upgraded some packages. But as soon as I built the initial algorithm, they changed the station ID because there's over 1,000 now. They were a 3-digit integer. Doesn't work very well when you get to 4. So they made it like a 16-digit hexadecimal character. So I had to rewrite the algorithm to point at a different variable. APIs become deprecated. Dark Sky API, shut down soon after I created it. They have the e-bikes now, the scooters. It is on the API as well. So maybe you can always revert to scooter if you don't want to take an e-bike. But yeah, things are always changing. You never know. So it's always keeping up with technology changes. And have fun. This is totally cool. No one asked me to build a data warehouse with 600 million rows and to present at a conference about e-bikes in Chicago and getting to work on time. But it's just fun. I think we all can learn. It's great to be able to do also yourselves. Sometimes we get very pigeonholed in a certain area we work in at work. This gives you the ability to build it from the ground up and really learn so much more and have a lot of fun at the same time. And lastly, I wanted to leave you with a few other things, but a few pictures from taking bikes around the country and world, testing out ones in Madrid or Barcelona, and biking through Alaska. Is life's like riding a bicycle. Keep your balance, and you must keep moving. I think there's a lot of similarities to us at work. Continuous innovation. We're constantly striving to keep up pace of technology changes, keep up with the industry trends. There's over 300 services within AWS. How can you possibly keep up with every feature release? Agility and adaptability. Knowing when to change your model, change your service and re-architect, but always keeping up to date. Embracing change. I think a lot of people didn't want to move to the cloud long ago. And so trying to keep pushing, keep striving, keep innovating is a constant piece. You're constantly changing when you're riding various terrains and routes. Perseverance. Learning can be hard. Learning to ride a bike can be hard. I think it's very similar to trying to do a cloud migration, for instance, or even just set up your first project within AWS. The cloud is you're bound to have shortcomings and shortfalls, but just keep pushing and striving to get it done and get that first iteration out the door so you can start iterating on top of that. And then balance. I think there's a lot of balance in bicycles, hopefully, but having balance within your cloud environment of, let's say, speed, security, agility, customer needs is a lot of similarities. And that's all I had. All the code I used is in GitHub right there. Feel free to fork it, clone it. PRs are welcome. Can we on Instagram or not Instagram? LinkedIn. It's right there. And are there any questions? We have a microphone, but I think I can hear y'all. Yeah, go for it. That's a good question. The question is, if I had to re-architect it today, what would I change? I would keep a lot of it the same. I think I think the Lambda function to save it is a great way. I think I'd architect I have a scheduled job in Snowflake to take out of the raw into the fact table. I think they can do a stream now, so I wouldn't have to do it every 15 minutes. I might make the web page. I'd start with Power BI instead of Streamlit, but I think there's some work to be done on like, yeah, just the ingestion into the fact table and in some enriching processes, as well as Data Robot did have some shortcomings of just scale. I initially did it with 8 stations, like the stations I cared about, like a few next to my house and a few next to work. When I tried to scale that out to every single station, it kind of choked on me. Had like a 10 gig ingest or like source limit, and so I think I'd have to like to break that out into every neighborhood. There's like 97 or 96 neighborhoods, so building a new algorithm per neighborhood would be a big change that would make it more accurate. Great question. Yeah. Anyone else? Yeah. So question is, did I ride a divvy here today? And did I consult the model? So yes, I rode a divvy here today. And well, that website was down. I actually did query the Snowflake database directly. But I also knew I was getting here pretty early and there was several available. But I wanted to make sure it was running effectively. But yes, I did take one today. And I didn't get sweaty, hopefully. So it worked out well. Anyone else? I think we got time for a few questions. I think I'm ahead of schedule. Yeah.
Probability.
That's a good question. I have the model at 80. That's where it is. Yeah, sorry, the question is, what is the threshold I use for if I'm going to take an e-bike or wait and go versus just go now and shower work? I think it's somewhat is depending on if I have time to kill. I can always just like take a train in. My model is set to 80% of what it predicts. That's the 80% threshold accuracy is what it uses for the visualizations and the predictions. I would say that's about right. It also just depends. Like if I'm going home, so I often like it works just as well going home, especially in the middle of the, late at night. You're like, I want to work late and I don't want to take, but yeah, I'd say 80% is usually like the threshold I use. Yeah. In a given time hour, because it might fluctuate throughout the hour. So if I can wait or just go there. But often there's pretty good density nowadays. You can use several as your source and combine those. So yeah, go for it. So I did want to, so the question is, I moved from Athena to Snowflake. What was the rhyme or reason behind that? I think performance, not that it mattered too much in my investigations, but Snowflake had like sub-second response or second response versus Athena was time intensive at times, as well as I kind of wanted to do some pre-processing and put it into a table, and essentially I'm just pre-processing and landing it and still doing the same process of just like reading a bunch of data. I didn't really spend the time to partition it. I kind of wanted to just work, as well as I think we were coming up on like a Snowflake summit and I wanted to test it out. But it did provide more performance. I did have, it was still a work account, so I didn't have to pay for it. It's a big reason why you might do something or not. But yeah, a lot better performance. Still had the infinite scalability like Athena would or Snowflake. I didn't really want to run a Redshift cluster at the time, and so I just wanted to adjust it into Snowflake as a way to test it out. Yeah. So yeah, performance would be a big one.
Station. Are there other cofactors?
So I thought about event data, like what is like a Cubs game make a big difference? I didn't really work in that. I know there's ability to like input like special events. But yeah, it was a very expensive query because like they're both epoch times and I had to like fuzzy join because I have 5-minute API access versus like every minute. And that was like it was literally just costing us some money in Snowflake. But yeah, in Data Robot, it just gives you like a report of like what's the biggest indicators. And it was nice because like I didn't do any data engineering besides like creating a Boolean function. Of like, is there more than one available? But yeah, it did all the look backs and it says like, the biggest indicator is like availability over 30, 60, and 90 minutes was the biggest indicator of anything, as well as like just other bikes. So you can use like, what's the volatility of non-e-bikes versus bikes? So essentially availability had almost everything to do with it. versus like, yeah, the weather for this case. But yeah, I thought about using like event data, like, I feel like Cubs games, United or Bulls games or Blackhawks might have a big impact, or if there's something else going on. But it seemed to be those, like the volatility was a proxy for those. So yeah, go for it. So it only does a 10-hour look back. So the question is, I think you guys can hear, but if I go to work at the same time every day, which I guess I actually don't go to the same time work every day, which is odd. Does it give me a summary of like, what's the probability over every day? It doesn't right now. The model essentially just does a 10-hour look back and 10 hours in the future. It certainly, if it looked back, last week, last month, last year, you might get a lot of indicators. At this time, I don't think DataRobot really supported it in this manner. I'm sure they might know how to use it better than I do, of how to do those look backs, and you get more accuracy for sure. Being able to correlate to like, what was it last, June 15th, and understand what that looked like, or last month. This is purely looking back. So unfortunately, even like, weekend to weekday, it might miss some things. It used that in the model. So it knows, it does that feature engineering based on what you learned. So I pumped in 10 gigs of data. I think that only looks back a month maybe. So it doesn't have that data. Question. I think we got time for one more, maybe. Anyone else? Yeah, go for it. So great question. So yeah, and a lot of people might not be familiar with Snowflake. So Snowflake is a cloud data warehouse. It runs in all the clouds. But the similarity in AWS would be Redshift. Especially, initially they had it be very tightly coupled from storage to compute. They've since created a new storage instance that is very similar to Snowflake, being a decoupled, infinitely scalable storage, and then having ability to provision different compute volumes on top. So yeah, DynamoDB would be the NoSQL. This would be essentially, you could use Redshift Spectrum, even possibly, would be like the similarities to Snowflake. Awesome. Thank you, everyone. I appreciate the time.